Hello! From the previous episodes, by the way, link is somewhere here, you already know how CSS in JS solved performance issues for us. But there is still an uncovered concept related to styling. This episode is about theming. As always, deep dive into architecture decisions and performance problems.
Before we start, let me quickly explain what we mean by theming. Theming refers to the ability to switch between different appearances of an application, such as changing from light to dark mode, modifying a brand color ramp, or configuring spacing among elements for better user experience. Users can switch theme through the application preferences or at the operating system level. Theming can also be controlled by the application. It can affect the whole UI or just a smaller part of the application. We call that scoped theming. In Fluent UI v0, the theme is composed of three main parts: site variables, where theme-wide tokens are defined; component variables, which are applicable to a single component. These should map to the site variables, but may also contain hard-coded values. And finally, component styles, which define the CSS for each component. The styles take component variables as an input, but they also have access to the site variables and actually to anything else. All these can be used not only as CSS style values, but also as conditional code. This architecture allows for a lot of flexibility. The themes are completely independent of each other, so they can define different variables and styles to achieve any desired look. However, there are also some drawbacks to this approach. The entire theme, including styles for all components, is represented by a single JavaScript object. This object cannot be tree-shaken, so regardless of how small part of Fluent UI v0 an application uses, the entire theme will remain in the application bundle. Theme merging is a complex task. For example, consider an application that uses scoped theming for a part of the UI. As described earlier, component variables depend on site variables, and component styles depend on both component and site variables. That means that component styles and component variables must be implemented as functions. And to merge themes, we need to merge site variables first, then component variables, and only after that can we merge the component styles. Merging in this context means invoking a chain of functions and merging their outputs. Theme merging is a performance-intensive task, and that happens with every component render. We have introduced multiple optimizations and caching techniques to reduce the performance cost as much as possible. But it still comes at a cost. Another challenge is the debuggability of styles. With multiple theme layer and complex merging producing atomic CSS classes, the result looks like an assembly that nobody is able to read or reason about. To address this issue, we introduced custom debug tool to help engineers analyze the merging process. In Fluent UI v8, the approach to theme is slightly different. Default styles are part of the components, while the variables are in the global theme object. It is possible to add component styles to the theme object as well. Those would be evaluated and merged with default component styles on every component render to allow style overrides. In Fluent UI v9, we learned from the v0 theming issue and built on top of v8 approach by incorporating component styles as part of the components themselves. This means that we no longer have a giant, single, unshakable object. It also means that the styles are always the same, regardless of the selected theme. This approach allows us to process the styles during build time and even extract them to a static CSS file. But wait a second, if the styles are always the same, how can we theme the application? The answer is simple: CSS custom properties, also known as CSS variables. These were not an option in Fluent UI v0 or v8, but in v9, as we no longer support IE11, we are free to use them. The theme in Fluent UI v9 is simply a list of tokens represented by CSS variables in the DOM. To switch theme, the CSS variables are replaced with new values, and the application's appearance changes without changing any other styles. Supporting scope theming is also as easy as applying the CSS variables to a DOM subtree. The only added complexity are React portals, as those are rendered out of the natural DOM order and therefore outside of the scope theme subtree. We need to guarantee that whenever a portal is rendered, the appropriate set of CSS variables is applied to its DOM.
There are two types of tokens in the Fluent theme: global and alias tokens. Global tokens represent a dictionary of available or valid values. For example, a pink color ramp consists of 12 slots which map to hex color values. These are the only 12 shades of pink available in the theme. The values of global tokens usually do not change among themes. For instance, pink shade 40 is represented by the same hex value in both light and dark themes. On top of global tokens, there are alias tokens which point to global tokens instead of hard-coding any values. While global tokens use arbitrary names like pink shade 40, alias tokens use semantic names like pink border active, which are easier to understand. The mapping of alias tokens differs among themes. For example, the pink border active alias token references pink primary in the light theme, but pink thin 30 in the dark theme. This is how theme switching works. In the Fluent UI v0 theme, all tokens are available in styles, but it is obvious that using a global color token is hardly ever correct. How often would you expect that a color is exactly the same hex value both in light and dark theme, or even in high contrast? To eliminate these bugs, Fluent UI v9 intentionally omits global color tokens from the theme. In the initial prototypes of the theme, we used a deeply nested object to represent the theme in order to provide a good developer experience for engineers. However, our assumptions proved to be incorrect. Instead of navigating a nested structure, we found that using IntelliSense on a flat object was much more effective. Representing the entire theme as a single flat object also made theme merging much more performant. Fluent UI v9 implements Fluent Design. But across Microsoft, there are another libraries for other platforms which implement the same Fluent Design. It would not be scalable to keep all the implementations isolated. Updating a single token value would require implementing a change in multiple repositories in different programming languages. As a solution, we use a token pipeline inspired by Style Dictionary. Designers maintain a JSON file which holds the single source of truth for all the theme tokens. They use the tokens from the JSON file in their design tools. Token pipeline transforms the JSON file into source code for all the platforms. Whenever we have been measuring performance in Fluent UI v0, we solely focused on JavaScript. All the computational work happened in JavaScript, so we could ignore all the other tasks in browser event loop. By introducing build-time style processing, static CSS extraction, and utilizing CSS variables, we offload more computations to the platform. Therefore, we need to zoom out and consider the other tasks in the event loop as well. The Fluent UI v9 team consisted of approximately 650 global tokens and 550 alias tokens. Adding hundreds of variables to DOM is not a big deal in JavaScript, but we learned that having those CSS variables present in DOM significantly affects style recalculation. In the first version, we injected all CSS variables for global tokens, and as CSS variables for alias tokens, we referenced the CSS variables for global tokens. In a test environment with 6 times CPU slowdown, we rendered 20 theme providers side by side, each inserting those 1200 CSS variables to DOM. After that, style recalculation takes up to 150 milliseconds. To optimize the performance, instead of referencing the global token CSS variables in alias tokens, we inline the values to the alias tokens directly. The inlining improves style recalculation performance by 40%. As described earlier, we do not want the global tokens to be used directly. With that, we can remove them, going down from 1200 tokens to 550. With that, the time spent in style recalculation decreased by another 40%. Actually, based on additional measurements, we believe the style recalculation time linearly grows with the number of CSS variables. The token names in the theme are quite long. By hashing them, we also tested if this somehow affects performance. But it seems that CSS variable name length has no impact. Let's summarize the differences in theming between v0 and v9. In v0, it is possible to have different component styles in different themes. In v9, the styles are always the same. In v0, styles are produced by a function evaluated at runtime, which allows using v0 variables in conditions. However, v9 tokens can only be used as CSS values. Is this approach flexible enough to satisfy all theming needs? Before choosing this approach, we validated it in v0. Even though the themes in V0 can use different styles, we were able to implement dark and high contrast themes on top of light theme by just overriding variables. Therefore, we believe this approach should be sufficient. But what if an application needs to use completely different styles? This is also possible by recomposing a component. All Fluent UI V9 components are altered in the form of hooks and a render function. Any application can recompose individual hooks and either replace or augment the styles hook to achieve its desired look. To use the custom theme, the application needs to be built using the recomposed components. However, this approach would not work if the application needs to switch between a standard theme and the custom theme. It also disallows code reuse between an application built on standard Fluent UI components and one that uses the recomposed components. There are also use cases where applications use standard Fluent UI V9 components but want to tweak a particular design aspect across the entire application. Let's take the example of customizing button corner radius. This was possible in both V0 and V8, but cannot be achieved in V9. Styles are static and cannot be overridden at application level. There is no support for component variables, as adding hundreds of CSS variables would have a negative impact on performance. Even if there were component variables, you could only tweak aspects for which we expose tokens. Any other tweak would require a new component token to be added. Supporting application-level style overrides or component variables would significantly increase the component's API surface. It would be challenging or even impossible to guarantee that the component would render as expected with all the possible combinations of props, component variables, and style overrides. Moreover, as Fluent UI V9 implements Fluent Design, overrides could cause the application to deviate from Fluent Design. These, along with performance concerns, are the main reasons why we have not supported such customizations. However, since this requirement is frequently requested, we are exploring various options for application-wide overrides, allowing style overrides through a React context, introducing component tokens by using CSS variables together with fallback values, or using Webpack aliases when building the application. If you are interested, you can check the linked RFC. And if you have any innovative ideas that we have not yet considered, please share them in comments. I have mentioned high contrast support a couple of times in this video, but never explained that. There are two different ways how Fluent UI V9 supports high contrast. Besides light and dark theme, there is a high contrast theme which maps all the alias color tokens to manually curated high contrast colors. The preferred approach on modern Windows is to use forced colors which follow operating system settings. We will dive deeper into this topic in an upcoming episode about accessibility. This is all for this episode. Thanks for watching and stay tuned.
Oh god, the answer is simple. This works when you try to engage. It starts to be creepy.
I am not the engaging person. I'm serious or looking serious, so that's what I should stick to.